such a global rise in temperature, 5, 6 degrees in a few decades. But the picture is a bit more complicated because, massive changes in the jet stream that we're seeing can cause a very large redistribution of temperature. It can kind of be, I think the methane's probably still required, but I think that there can be huge changes locally, like say over Greenland ice cores or over Antarctic ice cores in certain regions that can be, just be due to the jet stream changes.
But that methane gas, doesn't that in the atmosphere create the higher temperatures, more damage at a faster rate?
The methane, there's definitely more. Since 2007, we've seen a rise in methane in the atmosphere. It kind of flattened off, was flat for a decade or so. Started a sharp rise in 2007, and I think the levels coming up in the Arctic from the sources of methane is we get the permafrost and tundra thawing out. Methane that exposes the organic matter. It's broken down by bacteria and so on. And if there's no oxygen available, it's mostly methane that comes out. If it's near the surface and there's in a marsh and there's near the surface some oxygen can get down, then it's CO2 that comes out. But it's generally a mix of CO2 and methane, and the amount of either gas depends on how much oxygen is available. So we're talking about anaerobic or anaerobic decomposition. Now, so there's that source, but there's also these, the methane's also in the sediments on the seafloor. So the seafloor is warming. Over the eastern Siberian Arctic shelf, the water temperatures have risen, 5, 6 degrees Celsius. I'm talking about water temperatures over the seafloor. And this has caused thawing of those sediments on the seafloor and bubbling and methane up above the shelf. I mean, the Russian scientists have been measuring this. So this is another form, but also in the sediments, there's pockets of this methane, frozen in a water lattice, and these are the methane clathrates that people talk about. And Peter Wadhams wrote a paper. He looked at, what would a 50 megaton burst of methane over a few years or a decade or even a few decades, what would that do? And he came up with some 60, he came up with some $60 billion penalty or something. But, he worked with an economist, he tried to put a number on it. But these sort of things, these type of methane, it's only, if 1% of the methane in the Arctic was released, that would increase atmospheric levels, I think, a factor of 10 or something. And we're in a different planet. We're going to, because in the short term, the global warming potential at 1 molecule of methane, is close to 200 times more effective than 1 molecule of CO2. That's on a year or 2 time scale. If you go to...
But you and I are the only ones that know that. That's the problem. These people sitting in this room did not know about that.
Yeah, so people that, the David Archers and, the Gavin Smiths and some of these folks, who are go-to, media always goes to talk to them when methane comes up. They say, well, it's going to take a long time to come up, and the computer models show it's going to take a long time to come up, but the computer models mostly rely on how long it takes heat to transfer through a uniform material, like there's so-called slab models. I argued with David Archer, well, there's fractures in the sediments, there's areas where there's unfrozen and frozen, pockets, and if you get a small fissure and you get a little bit of methane coming up, then the actual methane coming up will make the hole will get enlarged and so on. And, you can't use a slab model, you can't So, you know, but it's funny. I don't understand the rationale, but you know, they say that it would take a long time to come up, and I just don't think that. You know, I think that's wishful thinking myself.
I'm worried about my great-grandchildren.
Your great-grandchildren. You might want to worry about yourself first.
I'm an old man.
As well, what I'm saying is that this is a problem. You know, people have been told repeatedly, 2100, by 2100 this can happen, by 21, you know, so then they worry about their great-grandchildren, their great-great-grandchildren. But, you know, we're seeing, you know, the time frames, you know, take everything that, I see those numbers, 2100, and I say, well, how about, you know, two decades or something, you know, for that type of thing. So, you know, it's you know, I think, you know, what we need to do, I mean, what we need to do is clear, I think, you know, I think that we need to slash emissions, there's no question. Okay, so there, you know, and things are starting to look up. I mean, Obama's talking about it, trying to do stuff, but it's mostly adaptation on his side. You know, there's divestment from fossil fuel campaigns with 350 now. A lot of the religious community is starting to say, yes, you know, we have to do something. You know, a lot of the university endowments and so on, the students have actually got them to divest from fossil fuels. I mean, things are happening, you know, but it's not nowhere near enough to start reducing emissions. You know, we're getting large increases in renewable energy. We're getting prices of solar and wind plummeting, and you know, we're getting rid of, you know, we're using less coal in certain regions, but you know, other regions are using a lot more.
In the 70s and the 80s, we had acid rain was the big problem, and we did do something about it here in the United States and stopped using coal with sulfur in it and creating sulfur dioxide in the atmosphere. China right now, I've been there recently, and I see those smokestacks blowing that cold smoke into the air. I'm telling you, this entire planet has to start becoming aware of the carbon dioxide that we're giving off. The plants eat that up and make wood out of it or whatever. We've got to start capturing the carbon dioxide and quit use so that we keep the methane gas captured on this planet and not in the atmosphere.
Yes. I mean, we need to slash emissions, there's no question, but we need to go do more than that. We need to, you know, I mean, if we could figure out a way to remove CO2 from the atmosphere to lower levels back to 350 parts per million, then that will go a long way to constraining the negative effects of climate change. We're still going to have lots of warming because of the built-in nature of the system and the lag time. It takes time for the system. You know, a lot of energy has gone into the oceans, for example, and that's going to be coming out. So, you know, but we need to do that. But, you know, if we have, you know, if the sea ice is going and we have food prices doubling or tripling in, you know, 2 or 3 year, 4 year time frame, then we need to seriously, you know, one of the things that Arctic Methane Emergency Group's been talking about for 2 years is, you know, we have methods perhaps that we could apply to try to cool the Arctic and keep the methane in place. But this is a stopgap. I mean, this is not a solution. We have to slash emissions. You know, this is a method. You know, the cooling of the Arctic method. You could Google us and see some of the things I'm talking about. But this is to buy us some time to, you know, if the extreme weather events get completely out of hand, as I think they will. I think that the what we're seeing now with the floods and droughts and things is just scratching the surface. I think as the sea ice goes, if it's gone in 2 or 3 years, and I think extreme weather events, the frequency, the intensity, the duration is just going to skyrocket up there. I think the you know, we're talking about an order of magnitude increase, ramping up
Yes.
10 or 20 times. And then, this will really, really wake people up, you would think, right?
I'm afraid it might be too late then.
Well, too late for what? When you say too late, what do you mean? Like, okay, so we'll spiral up and we're all going to perish off the planet, or like I guess when too late, is very, it doesn't matter. Like if it's too late or not, we still have to try to do it.
We got to start trying.
I mean,
and
we
now,
have to try to do it. I mean,
need
the
to know.
idea of reducing growth. The idea of sustainability, all of those things will be tossed out, and the idea, the meme or whatever, will just be survivability. How can we grow our food? How can we get our water? How can we deal with the extreme weather events, right? So, it'll be survivability. Right, all the university departments that have formed in the last few years for sustainability will become survivability. So at least they can reuse some of the letters that they have.
Thank you. Let me have some of the other people talk to you here.
Sure.
Would someone else like to ask him a question, Peter?
Come on.
Come on up, Peter. That was great.
Hello, sir.
Hi, how are you?
I'm good. So the methane group that you're part of, can you give a short synopsis of what the projections are for our methane game?
Yeah, so there was a conference, I guess, when was it? About 2.5 years ago in the UK. A bunch of people there, the scientists and a filmmaker and a medical doctor and a bunch of retired people. I guess they got tired of playing chess at the bridge at the local club, and they started worrying about the methane and the climate and so on. So they had a sort of a kickoff meeting, and I found out about them about a month later because my thinking was very aligned with theirs, me not even knowing about them. And so basically it's an email group for the most part. We exchange ideas. We put together presentations. There's a web page, a website, which is not kept up very well. But we mostly exchange ideas. So the view of the Arctic Methane, the group, is that we have a huge problem, right? There's no change in the thinking in the last 2 years, 2.5 years. I mean, all these ideas and things were there. What's happened is that in the last 2.5 years, there's been a heck of a lot of change in the climate system in terms of extreme weather events, in terms of melt rates from ice caps. And so the whole premise is that the methane in the Arctic is going to be a problem. Okay?
Right, and you spoke about
the sea ice going, we get the sea ice melting out, we get the warming accelerating, we get large releases of methane from the Arctic coming up, causing additional warming, and we reach this scenario where we jump up in temperature to a different climate state.
Right,
very
and
quickly over
that's
a
the
decade or two.
right. That's that order of magnitude you're talking about, and the feedback
Yes.
loops, how they keep feeding
Yes.
each other and theoretically make these time periods go by much faster. Because I think I heard something that not too long ago that you had said that you were thinking maybe the 2100 or 2070 or something, and it seems like your timeline is coming down.
Yes. Yeah, I mean, I was talking about, with 2070, I was talking about sea level rise and so on. Like, I think, we're just, we're gambling, really. I mean, we've thrown the precautionary principle, out the window. I mean, we're talking about, up to now, I mean, this has been, the probability, the risk has been hard to assess from things like methane and that, because it was thought that the probability was extremely low of methane coming up. In fact, even in the latest IPCC report, they don't consider methane a big problem. But even if the probability was, the Arctic methane, even if those worries, even if that was like a 1% probability of occurring problem, it changes the entire world. So the risk is the probability times the significance or the effect, right? And if the effect is everything changes,
yeah,
right? And even a 1% is, it's saying you need to look at the problem. We need to measure more. We need to have better measurement of methane in the north. We need to, we need to have more collaboration between the scientists. We need to, let the public know what's at stake. The Russian measure, the observations the observations of methane coming up from the eastern Siberian Arctic shelf show large increases in the amount of methane in the size of the area where it's bubbling up from.
Right, and that giant hole?
Measurements show large amounts of methane coming up, and we know it causes warming. So I haven't done all the calculations, but one of the papers I'm working on would be to look at, how much local warming is there in the Arctic because of the methane that's already coming up. I think it's pretty significant.
Right, and how about that big hole in the ground the last few days?
Well, that big hole in the ground is interesting, right? Because I was just having a look at it about 10 minutes before our call here, because it looks like a Photoshop hole in the ground, and then you see the video from the helicopter flying over it, and you see the edges and so on, and it's got to be methane-related phenomena, I think. I don't think it's a meteor impact, and I don't think. One of the theories is that it's like this Arctic type of feature where you have a big ice chunk creating a hill, and then the ice expands, it pushes dirt to the side, and then melts and creates a hole, like a sinkhole type thing. So yeah, it's interesting. There's people there doing measurements. So we know.
And then I guess the only way to stop, or is it the only way to possibly stop the methane challenge, is to attempt to geoengineer our temperature from rising and the CO2. But are there any technologies that are close to that eat CO2?
Yeah, I think we have technologies that could do it, actually. Right? I don't think it's a technology issue. I think it's a political issue. It's recognizing that this is a huge problem and we need to try to do it. Right? I think that's the issue. I thought that I did a blog. I don't know, a long time ago, over a year ago. I called it, if you Google anthropogenic Arctic volcano, you'll find my blog. I chose that title. It's a good title, right? So I thought that if you simulate a volcano in the Arctic, the sulfur dioxide is going to cause the cooling. But then there's some people that were arguing that, well, that'll only happen in 6 months of the year. During the winter when it's completely dark there, right, there's no sun coming in there, so all of this extra sulfur dioxide in the atmosphere would actually stop, it would actually stop radiation of energy out to space. So it could actually cause warming in the winter and cooling. It does the cooling in the summer when the sun's there, but it can actually cause warming in the winter. So then Stephen Salter is one of the AMAG people, and he's on the forefront of geoengineering. I think I don't remember if he's at Edinburgh or anyway. He's talking about using these big towers to evaporate seawater and spray salt spray into the atmosphere, making low-lying clouds to cause the cooling. And then if you shut off his device, those clouds are gone in a week or two. So that would maybe get around the problem of of causing the warming in the winter that the sulfur might do. So there's lots of people that are looking at this sort of thing, but it's certainly, I mean, the ocean acidification problem requires a removal of CO2 from the atmosphere. So any of these other methods, the sulfur dioxide, the water spray, they do nothing about ocean acidification. I mean, they would be stopgap measures to try to restore some semblance of jet streams that we're used to, while emissions are being slashed. I mean, they would just sort of buy us some time, but we need to get CO2. We got to stop dumping it in the atmosphere. There's no other option.
Thank you, Paul. Thanks for answering about that. I was reading about that hole in Siberia, and so thanks for answering that.
It looks really weird, doesn't it?
Yeah, it does.
Like it's.
It doesn't look real. It was like I had to really look at it. Like, is this photoshopped? Is this?
Yeah. I mean, you can Photoshop a movie too, right? If you just.
Yeah.
Like if you have enough time, you can Photoshop every single frame, put it together, and it looks like a movie. Like you see the guy walking across the swimming pool on the surface of the water. I don't know if you've seen it.
Yeah.
I mean, that one apparently uses some guy wires and stuff. I mean, I was looking at it closely, thinking, is this Photoshopped every frame?
Yeah. You really have to check, don't you?
But some of the images of clouds and storms are incredible these days.
Yeah.
You think this is fake. This is fake. I used to post those, and there was a retired meteorologist, Bob Jones. He'd always come on and say Photoshop, 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 right? But some of them now are just. I mean, it's the Weather Channel posted, right? Usually they're pretty good. These storms look like they're just out of a Hollywood movie or something, right? I mean,
yeah, they do.
Yeah.
I had a question for you, and I have another question.
Yeah.
Why don't you come over here and sit down first?
I don't know if it's a dumb question or not.
No question is dumb.
Hi, my name is Holly. I want to know, is there a relationship between extreme climate change and earthquakes that we've been having that seem to be larger, or appear to be becoming larger anyway, the earthquakes?
Yes. That's an excellent question, and most people would have told you no to that question, but not myself, and not Bill McGuire. Bill McGuire I think he's a geologist, or he's an earth scientist, and he's been looking at this issue, and he wrote a book. About a year or so ago. I'm trying to remember the name of the book. It's something about the angry Earth, or I don't remember the title. But if you Google Bill McGuire earthquake climate change, you'll find it. But the idea, okay, so we know that glaciers that melt very quickly. Okay, ice is heavy, right? But the ground that it's on is heavier. So the ice, the density of the ice, the mass per given unit of volume, is about a third that of the soil typically. So if you've got a glacier that forms on land and the glacier is a mile thick, then it actually will push down the land about a third of a mile.
Ooh, so it'll make the plates move.
Yeah, it pushes it down. The weight of this ice just sitting on that ground, it pushes it down. And then as the ice melts, then the weight is less and less, so the ground can come and rebound up. And that takes time. In fact, over parts of where we did have big glaciers on, up in northern Canada and in Siberia and in Europe and places, the ground was pushed down. And the peak of the ice age was about 20,000 years ago. So since then, I mean, the ice melted off. Most of it was gone, by about well, 10,000 years ago. The last remnants in Canada, anyway, were gone about 8,000 years ago. So ever since then, the land has been moving back up.
It
right?
takes that long.
But when you think about it, right where the ice is sitting on the land, it pushes it down. But then outside where there's no ice,
pushes it.
the land actually has moved up a bit. But because the ice was pushing land down, that land has to go somewhere, so it kind of sloshes to the side, and you can get a rise at the edges. So now with the ice is gone and the land is rising there, the edges could be falling, right? So when you measure sea level, you have to be very, very careful. But so the thing is if you move, so when there's areas, people have been looking in the records, and when there's been periods of very rapid ice melt, there's been larger numbers of earthquakes and larger numbers of volcanoes. Okay, so what we're seeing in Alaska, they call them ice quakes, and because of some very rapid melting of the ice, the land wants to rebound quickly, and it causes earthquakes and causes, you can get volcanoes. So what we're also seeing is another factor is if you have a volcano, that's not active, right? The magma inside builds up pressure over time, and then the thing erupts. But if if it's been building up over time, and then you get extreme rain events, so you get torrential rains on this volcano, if it causes a landslide on the top of the volcano, then all that earth, or one part of it moves down, that relieves the pressure, so that landslide can actually trigger the volcano to erupt. So it's interesting because some volcanoes can be triggered by a large movement of earth on the top of the volcano sliding down. So it's all connected.
It is.
What you have to look at is when you talk about connections and whether one thing affects another thing, you always need to keep in mind the time scale. Okay, because the time scale is very important. So if you don't ask about the time scale or include it in your question, there's not really, it's really difficult to have an answer, because if your question was saying instantly, does climate change instantly cause a volcano? And maybe the torrential rain could do it, but in terms of the rebound effect, there'll be some sort of time has to go by before there's the volcano is triggered, or before there's an earthquake. We're finding out that we pump water and different chemicals deep into the earth, and to fracture rock, and we're lubricating faults, and we're causing earthquakes, right? So human, it's interesting. I mean, we have our climate deniers. Are there fracking earthquake deniers? There are, right? There's people that are saying, fracking doesn't cause the earthquakes. But I think, look at Oklahoma and the number of earthquakes. And their proximity to fracking, like it's it's pretty obvious, right? That so what do we call these? Anthropogenic earthquakes. I haven't seen that term. Human-caused earthquakes. We cause earthquakes. So all of these processes